Okay, today is our last day of angles and arcs. We are on day 6, where our angles are now outside the circle instead of being inside the circle. This is page 22 in your packet. And if you look here at the top of page 22, you're going to see, I'm going to highlight these, you're going to see how this angle outside the circle can look different. It can be that kind of angle where the secants are cutting through the circle. It can be that kind of angle where they're both tangents, and it can be that kind of angle where you have one tangent and one secant. And just to be really clear, B is the vertex of these angles. So the angles would be right here. They're just not inside the circle anymore. And so the only way that this changes, we still have 2 arcs. I'm going to go through, let me go through and highlight those real quick. Still have 2 arcs, one there and one there, or in this weird case, one there and one there, or one there and one there. So it just depends on the way that the angle is formed, if it's formed from 2 secants or 2 tangents or one of each. But if you notice, the formula stays the same. It says the angle is equal to the big arc minus the small arc divided by 2. And if you remember back to day 5, I'm going to scroll back here just a little bit. Remember, we were adding the arcs and dividing by 2. But now the only difference is we're subtracting the arcs. And we just want to make sure that when we subtract the arcs, we do the big arc minus the small arc, because we don't want to get a negative number. So just filling in the notes here, when the vertex of an angle is located outside the circle, the angle measure is half of the difference meaning subtract, of the intercepted arcs. Okay, so sort of sloppy, sorry for my writing there. So let's look at a couple of examples, and then we'll come back together and we'll work some. Now here, they would like to know the measure of angle 1. Well, hopefully you can see that that 1 label is outside the circle. Angle 1 is that green angle, okay? And it does have 2 arcs. Let me get a different color here. It has this 80 because it touches at S and V, and it has this 40 because the secants touch at T and P. So if we do angle equals big arc minus small arc, oops, that was right arc there, divided by 2, we have 2 arcs, one of which is 80 and one of which is 40. So we need to do 80 first because that's the bigger arc. And we can probably do this particular problem without having to worry about Desmos. We could do 80 minus 40 is 40, and 40 divided by 2 is 20. Okay, so that's what we're doing. Of course, there will be situations where we have to solve for a missing arc and not a missing angle, but I'm going to show those to you in class. Let's do one more like this, and then we'll come back together. So here we have the measure of angle 2. Angle 2 is outside the circle. And angle 2 does have 2 intercepted arcs. Only they just look a little bit differently because angle 2 is formed from a secant, and the secant is this top line from z to w to x, and a tangent, a z to y. So it just looks a little bit different, but the formula still applies here. I'm running out of room, so I'm not going to write my formula, but you can see that I have a big arc, which is 160, and I have a small arc, which is 80 over 2. So I'll have 160 minus 80, which is 80. And when I divide 80 by 2, I get 40 degrees. Okay, so we will come back together. We will be on page 23 at the top, and we're going to practice some of these other cases together where it's not quite as straightforward. Notice on those two problems at the bottom, let me scroll back down, I did not use Desmos at all. You still can, but some of these other problems, when we come back on page 23, they are definitely going to need us to be using Desmos on them. See you soon.